the problem which we have taken now, in this problem, the machine or the transmission line impedances, they were given, and then we have converted into its per unit system, into its per unit quantity by defining one base value of the power and the voltage. Now sometimes generally if you see the nameplate of the machines or the transformers, they will give you the per unit quantity as well. Instead of giving you the actual values, they will give you the per unit quantities. And now you are using two different quantities, like now you are using, let's say, two different transformers, two generators, so different, and all those per unit has been given. So obviously we know that in a per unit system we need to define the per unit quantity, let's say impedance. It is based on the base value, what base value was chosen. So let's say a transformer. So in a transformer, if the per unit, let's say the series impedance and shunt branch parameters are per unit, they are given in per unit system. So obviously that means it has been defined for its rated voltage and apparent power. Okay. Similarly, the other machine, they have given you the per unit, and let's say the voltage rating and the power rating is different there. So obviously the per unit quantity, the per unit quantity of those parameters would be different. Now if you are using, let's say, 2 or 3 machines with different per unit quantities that has been defined for different base values, then obviously that won't form a common circuit now. So you have to convert the given quantity in per unit to a new per unit quantity. If you are, let's say, if you are connecting a machine whose base, two transformers whose base voltages and series parameters and shunt branch parameters, they are all given in per unit. So their base voltages and apparent power of both the transformers are different. Now you want to connect those two transformers in series. Okay, in this previous case, and so how you will do it? Because the internal parameters they have been defined for the different base values, different power values, and different that is apparent power values and different voltage rating. So now you have to define the new per unit system. Okay, so one way of doing it, from the given per unit quantity, you can actually compute back the actual quantity and then you calculate in the per unit, in the new per unit system. So, or other way around is, there are some expressions which is based on this concept only, where you can easily compute the new base quantities, like the per unit in new base quantities. Okay, let's say why do we need these kind of conversion from old base to new base? This is the case when different machines whose parameters are given in per unit and these ratings of these machines are different. That's why we need to convert it into a common per unit system. The parameters should be in a common per unit system. Okay, keep that in mind. That's the important thing. The parameters, if we are defined, if the parameters of the machine has been defined in per unit, that has been defined for a particular base value of the power and particular base value of the voltage. And if we are using the same machine, the different base values of the apparent power and apparent voltages, different base values of the apparent power and base value of the voltages, then we need to convert it into new per unit system. Okay, so let's say if different machines whose parameters are defined in per unit is required to be used for in one network, then we need to recalculate the per unit values, or we need to find the new per unit values. Okay. So to find the new per unit values, we need to first define the new base values as well then, right? So let's say S per unit, I would say old is, that S actual upon S base old, and V per unit would be V per unit, or I would say and let's say S per unit for the new system would be S actual upon S base new. Okay, so SPU per unit in new base, it would be upon S per unit old, it would be equal to so S actual upon S base new into S actual upon S base old, right? So this actual is cancelled out, and this would be equal to, so S per unit new is actually equal to S per unit old into S base old upon S base new. So this will give you the new apparent power or new per unit quantity of the apparent power in new base. Okay, this will give you the per unit of the apparent power in new base. Okay, if old base was defined and you have changed the base quantity, so this will change. Similarly, you can find VPU new as VPU old into V base old upon V base new. And if you want to have the similarly I per unit new, I per unit old, you can calculate, it will go like that. Similarly for, let's say, R, X and Z, all this in per unit defined in new. So if you are using that expression, the square one expression, right? So it would be R, X, Z all in per unit old quantity into V base old quantity whole square upon V base new whole square into S base new upon S base old. Okay, so if these parameters are given in the old per unit quantity in a different per unit quantity which has been defined for different base voltages and power, then and you want to use these parameters in a new parameters of a machine or different machines in a single per unit system, then you need to convert it, right, as per the actual base values there. which you have chosen for your entire network. Okay. Now let's say the transformer, like where we have calculated the equivalent parameters, the shunt branch parameters and series branch parameters. There we have calculated it in SI units. Okay. So sometimes for the same machine we need to find the per unit impedances of these equivalent circuit parameters. Okay. So how do we find it? Okay, let's say we have computed after let's say shunt branch, after open circuit test and short circuit test, we have actually computed the equivalent circuit referred to the primary side as this value. This was in one of the previous problem, right? This is the equivalent circuit diagram. Obtained from OC and SC test, referred to of a transformer referred primary side. Okay. So, and the rating of the transformer was, let's say, 15 kVA and 2300 by 230 volt. Okay, this is the rating of transformer, and this is this equivalent circuit diagram is when it has been referred towards the primary side. So question is, find the per unit equivalent circuit diagram of the given transformer. Okay. So since this is towards the primary side, this equivalent circuit diagram has been given towards the primary side, and primary side voltage is 2300. So base voltage, so V base would be 2300 and S base would be 15 kVA. Okay. So what would be these we need to convert these impedance. Okay. So what would be Z base here? So Z base would be V base whole square upon S base. So once we know the Z base, we can convert these impedances to in per unit system. So V base is 2300 whole square upon S base is 15,000 VA. So this would be in ohms, and this will come out to be 352.66 ohms. Okay. So now you can easily convert these impedances directly, right? So RC per unit would be 105 kilo ohms upon 352.66 ohms. This will come out to be 297 per unit. XM would be 11,000 ohms upon 352.66 ohms, and this will come out to be 31.19 per unit. Similarly, you can find R equivalent in per unit, which would be 4.45 ohms divided by, this is the given in SI, and the shunt the base value for this would be 352.66 ohms, and if you calculate, it will come out to be 0.0126 per unit and X equivalent per unit. These are all referred towards the primary side. Because this equivalent circuit diagram has been given for the primary side. So this would be J 6.45 ohms upon 352.66 ohms, and this will come out to be J 0.0183. This is A 0.0183 per unit. Okay. So this circuit has, in per unit, if you will see, this has become 297 per unit. This has become 31.11 per unit, and this has become 0.012126 per unit, and this has converted to 0.0183 per unit. We will solve one more problem where multiple machines would be there given in per unit system parameters, and we'll see how to use the concept build up here. Okay, so we'll stop here for today, and that completes the per unit discussion on per unit system. Thank you.